Hello students, welcome back. We just completed 3 out of 4 domain problems. These 3 we did, and this one I left it as an exercise to you, the hardest problem. Alright, let's go over to the next set, asymptote problems. Actually, these are the same problems as before. I mean, not the same problem, same functions. You see, same functions here, but just analyze asymptotes this time. Linear asymptotes, by the way, not curved asymptote. How about the first graph here? Well, I'd like to save some time, so instead of going to Desmos graphing calculator, let's just do it here. Graph looks like this. It's kind of parabolic like this. No vertical, no horizontal asymptote. How do I know for sure? Vertical asymptote, set the denominator equal to 0, and I have no real solution. So no vertical asymptote. Horizontal asymptote, we can use the asymptotic estimation. Take the leading term only, and then the rest, you can ignore those. Take the leading term only, and the rest do not contribute. So what do we have? We have 2x to the 4th power over x squared, so that's 2x squared, and thus this function behaves kind of like a quadratic function or a second power function, so it's going to be a U-shaped function, as you saw before. U-shaped. So, no horizontal asymptote, no slanted asymptote. Oh, by the way, about this radical here, square root is 1/2 power. So this growth order is 1/2. This is 3rd power, this is 4th power. So which is the leading term? 4th power is the biggest. And down here, 2nd power is the biggest. That's how the asymptotic estimation works. How about this problem? Okay, again, we went through this already, so I don't want to go back to Desmos graphing calculator. I'll just save time with this graph here. Apparently, we have 3 vertical asymptotes, and if you remember, x equal to -1, x equal to 0, and x equal to 3/2. And then we have 4 curved pieces, but more importantly, we have horizontal asymptote forming here, and also there, and they are 2 different horizontal asymptotes. Remember, rational functions always have 1 horizontal asymptote or none. To the right or to the left, they make no difference. For algebraic functions with radicals, things can be different. How different? Well, let's check. Vertical asymptotes, we already did previously. Set the denominator equal to 0 and factor it. You can solve it. Oh, excuse me. I think I have a typo here. Okay, all right, now it's correct. Sorry about that. Yes, this is correct factorization. Yes, 3/2, 0, -1, okay. -1, 0, 3/2, okay, all right. Corrected now. So vertical asymptotes, okay. We have 2 horizontal asymptotes. One here to the right, one there to the left. Why is this happening? This is very, very important in calculus. And after all, everybody here is taking this course because he or she is headed toward calculus. So this is going to be important. Font is too big, it's a little bit difficult to work out. Okay, just do it here. Alright, let's do asymptotic estimation, which means we'll take the highest degree term, and the others, not that important, so de-emphasize them in gray. Highest degree term, and then the others not that very important. And then how about inside of the square root? This is the highest, 6th power is the highest, and then the others are not very important. So de-emphasize them in gray. Actually, good students must have seen this one too is not important as well, because you see 6th power and inside of the square root, so 6 divided by 2, so this growth order is 3. This is actually degree 3. And then this one has degree 2, so this one also goes out. But for all the students, even for below average students, let's do it this way. Just take the leading terms outside and also inside of all those, and then go from here. We have 3 terms now. Denominator, we just have 1 leading term. Numerator, we have 2 leading terms, 1 outside, 1 inside. And then 1 inside, let's work it out. Square root of 9 is 3, and then square root of x to the 6th power is 3rd power. So we have 3x to the 3rd power. Do you see that? Do you see the highlighted part? Now, 5x squared, that's not important anymore because we have 3rd power now. So throw that away. And what's left is 3x cubed over 2x cubed. Simplifying into 3 halves. That is a horizontal asymptote. Right here in blue, 3 halves. But then again, how do you get the other horizontal asymptote? Well, we do the same thing down here. We simply take the highest degree terms, the leading terms, and then let's focus upon this square root, which is highlighted in red now. Square root of 9 is 3, and square root of 6 is x to the 3rd power, but there's a catch. This square root here is always positive because this is positive square root. But if I simply take 3x cubed, that's going to be negative because x is going to the left. So how do you make a negative number into a positive number? I need this extra negative sign. That's where we have the sign change. And after throwing this one away, you get negative 3 halves. Negative 3 half here. Now, when do we have this kind of sign change and when do we not? From positive infinity to negative infinity, do we always have sign change? No, that's not the case. For rational functions, there's no distinction. Actually, the reason we have this distinction is because we have 3rd power here. That's odd. So negative to the 3rd power is odd. Negative to the odd power is negative. And that's why we are having the sign change. But that logic is a little bit difficult to handle. If you can understand everything, fine, but much better way is down here. Always begin from the graph. Graph the function, and then anticipate 2 different horizontal asymptotes, here and then there. So 2 different horizontal asymptotes, which means we have sign change. One for plus infinity, no sign change, straightforward. And then we have sign change for radical, for negative infinity. How do you know? Let me emphasize again, it comes from the graph. In calculus, we have to do this, and I really emphasize graphing there, but over half the students do not bother with graphs, and mostly they get it wrong because of this, because they didn't bother drawing the graph. You don't really have to draw the graph, just use Grapher, use your graphing calculator, graphing tool. It should not be too difficult. But if you neglect graphical information, sometimes, as a matter of fact, forget sometimes, many times, things can get terrible. So synthesizing graphical and algebraic information together in the same problem and helping each other is actually important mathematical skill, and you're working on one of these here. Okay, we went through an horizontal asymptote problem, and for radical function problems, sometimes we have the same horizontal asymptote. In that case, you don't really have to worry about the sign change. So how do you know? Graph it. Here's another problem, And I really wanted to emphasize the sign change, so I wrote another problem with sign change, as a matter of fact. I could have selected a problem with no sign change, like, okay, this kind of problem, but I decided to do it twice. The key again is the graph. You see, if you graph it and you have two different horizontal asymptotes here to the right and here to the left. If you graph it, you'll know. Okay, because you graphed it, you anticipate two different horizontal asymptotes. So let's go ahead and do that for this problem. Okay, how do we handle that? Take the leading term, and then this one is not very important, so de-emphasize it. Take the leading term, and this one is not very important, so de-emphasize it in gray. This one's important, bold, and then these not very important. And we have to do the same thing down here as well. Okay. Maybe I can increase the font a little bit. Okay. So after taking all those leading terms, both inside and outside the radicals, and then we can simplify. We have x from the numerator, 2x from the denominator. This square root of x squared, which I just highlighted in blue, is simplified into x. Square root and square cancel each other out. We have just x. So we have x over 3x. We have 1/3. That was easy. Plus direction is always easy. For negative direction, it can be tricky, especially if you use logic. So this square root is always positive. And then if you just have x, that's going to become negative infinity. So we need this extra negative sign. But that's a hard way to do it. Easier way to do it is to look at the graph and anticipate two different horizontal asymptotes. Okay, we are going to have sign change. So don't think too deeply into it. Just go ahead with the sign change. And then we have x over x, so that's 1. And there goes your horizontal asymptote. And let's come back to the graph. Does it match the graph? Yes, indeed. Vertical asymptotes, well, that's something we already did, so let me go ahead very, very quickly. When we did this domain problem, we went through the denominator already. So set the denominator equal to 0. This is a radical equation. So flip the other side to the other, and then we have square root is equal to something, and square both sides. We have complete square, and we have quadratic equation to solve. Sorry about the typo. So it'll turn out x equal to 5 is extraneous. We only have x to the 4/3. And that is the vertical asymptote. Right here, x equal to 4/3. That's the vertical asymptote. So the vertical asymptotes, setting denominator equal to 0. Horizontal asymptotes, asymptotic estimation, but be careful when you have two different horizontal asymptotes, for instance. Do we have enough time for the fourth problem here? I don't know. What's the graph? Graph kind of looks like this, and can you make any sense out of it? Maybe not. And in a little bit bigger plotting domain, you can see vertical asymptote forming. But no horizontal asymptote, no end behavior. So you don't really have to worry about horizontal asymptote or slanted asymptote. Just vertical asymptote only, and look at the previous problem. The same denominator. So same method, same solution. The vertical asymptote will be same 4/3. X equal to 4/3. Okay, that concludes this section 1, and I guess that's it.